All right, let's look at images being created in a convex mirror, so in a diverging mirror. In the previous video, we looked at a concave mirror. Instead of using an arrow, which is commonly used in a lot of examples, we instead used a little stick figure. So we're gonna do the same thing here. So on the side of the mirror, all right, so on the outside of the mirror, we have our little stick figure. So we're gonna use our principal rays to actually figure out where the image is gonna be created. Now, we're gonna start off with, and just like we did with a concave mirror, we're gonna use the top of the head as our reference point. And we have our stick figure resting on the principal axis. And as we said in the last video, the whole point to that is that it makes things a lot easier for finding the image, because with a complicated object, you need to find 2 points in order to properly find where the image is. By putting it on the principal axis, it makes it a lot easier for us to find that actual position. All right, so our first ray is going to come in parallel to the principal axis. And as always, drawing in our arrows to indicate the direction of motion, or the direction that the light ray is traveling. When it comes in parallel, it's going to bounce off like this. It's going to appear to come from the focal point, all right? And I'm going to extend this way back, because as we mentioned in the last video, we really don't know where this where this image is going to end up being. So we're going to give ourselves a nice long extension just to make sure we can find it easily. And again, make sure we have our arrow showing the indicating the direction of travel. Our second possibility is aiming directly at the center of curvature. So we will aim at the center of curvature, and this time it's on the other side of the mirror, so it's pretty easy to find. And when we aim at the center of curvature, it's going to bounce back and head out off that direction. And as we did in the first one, we're going to extend back behind the mirror. All right, so we've got, it travels in this direction, but it will bounce back out in this direction as well. And we can already see we've got a point back here where these are actually going to cross, but let's verify. All right, so we are going to now aim for the focal point. And when we aim for the focal point, it should come back. And aim for the focal point, it will come back parallel to the principal axis. Now, this is the one ray that students often make a mistake on, and that is because they extend this ray back. But remember, the ray that you are extending back and behind the mirror is the reflected ray, not the incident ray. So you're not going to extend this one back, because this is going to go through the focal point. You're going to extend this one back, the one that came out parallel. And when we extend this out back, what we find out is that all three of those lines extend back to a position right about here. So that's where the top of the head is going to be. Now, again, reminder that the whole point to us using the principal axis as one of the ends of our object is because then it makes it much easier to find where the image is going to be. And all we have to do is take this point on our image and extend it down, and this will be where the feet of the object's image will be. All right, so the head will be here, and we'll draw our little body here, and that's where our image will be. So once again, we have to do salt, and what we'll find is that no matter where we position our object, anywhere in front of the mirror, the salt for our image will always be the same. The size will always be smaller. Again, apologies, I'm writing upside down, so lettering may not be perfect, so it will always be smaller. The attitude will always be upright. The location is always going to be behind the mirror, and the type will always be virtual, because a reminder that If the light rays had to be extended back, that means the light isn't actually going there. Only real light rays can make a real image, so this will have to be virtual.